Hello everyone, my name is Rohit Singhal and we were discussing about the topic hydrocarbons. In the previous classes I have started with the aromatic hydrocarbons. I have discussed how to synthesize in the laboratory, then I have discussed a few physical properties of it. I have briefly discussed that what kind of chemical properties we have to study of the aromatic hydrocarbons. Aromatic hydrocarbons undergo the substitution reaction unlike the alkene moieties which normally go the addition reactions. So, the substitution reaction, which kind of substitution reactions now it go, let us discuss it. So, normally we will discuss benzene only. Okay. So, substitution reaction it gives. If you remember, I have already discussed that alkenes are the rich source of the electron rich source, same as case of benzene. These also have the electron rich source, and if there is an electron rich source, that means it will give an electrophilic substitution reaction. There are two kind of substitution reaction possible: electrophilic and nucleophilic. Electrophilic where means a electrophile will attack, and nucleophilic means a nucleophile will attack. What is an electrophile? What is a nucleophile? Electrophile nucleophile. Electrophile means electron deficient. And nucleophile means electron rich. So, now there is which kind of substitution reaction does benzene does is actually benzene is an electron rich source. Okay. If benzene is electron rich source, it will obviously react with someone which do not have the electron, means which have the electron deficiency. So, that is why benzene reacts with the electrophile, and if the benzene reacts with the electrophile, that means an electrophilic substitution reaction. That means we have to study electrophilic substitution reaction. Say benzene gives electrophilic substitution reaction due to its electron rich nature. It has high electron density, that is why benzene reacts with someone who do not have or who loves to have the electron density, which do not have the electron density and electron deficient, and that are called electrophile in our terminology. So, science terminology, that is why we called this as the electrophilic substitution reaction. Whereas nucleophilic substitution reaction, nucleophile reacts with those moieties which are electron deficient. So, electron deficient molecules or react with someone with has a higher electron density, that is why it is the nucleophile, and those reaction will be known as the nucleophilic substitution reaction. But now as of now we have to discuss the reactions of benzene. So, benzene is electron rich species, and we will discuss the electrophilic substitution reaction. So, let us start with the electrophilic substitution reaction of benzene. Okay. What does this electrophilic substitution means? That a benzene, the hydrogen of benzene will be replaced by an electrophile. I am showing the positive charge because it means the electron deficiency will be replaced by an electrophile. The hydrogen will be replaced by an electrophile. This will be called as the electrophilic substitution reaction. A lot of such electrophiles that benzene shows, it can be nitration, it can be sulfonation, it can be any alkyl group, it can be any aryl group, okay, or it can be any halogen or something. So, if a nitro group is being introduced by replacing hydrogen, it is known as nitration reaction. If by this SO3H, this will known as sulfonation. If by alkyl, this is called as Friedel-Crafts and if by aryl, it is called as Friedel-Crafts. What aryl it is, sorry, I am taking about the acyl group. Okay, I will discuss what the acyl group is. So, this kind of means depending upon which electrophile is being substituted to the benzene ring, there are different names to the reaction. If it is substituted by the nitro group, it is called a nitration reaction. If by an SO3H group, that is called as sulfonation group. If by any alkyl group, that is called a Friedel-Crafts alkylation. If by acyl, then Friedel-Crafts acylation reaction. Now, we will discuss one by one and we will discuss the detail of these reactions. Start with the nitration reaction. Nitration reaction. Now, the thing is nitration reaction, I can't like do this that nitro group is introduced and it will give this nitration. No, this such case will not happen. Okay. So, actually there is a common thing that this actually is not a nucleophile electrophile, this is not a an electrophile. So, what we have to do mainly first thing is that in any case of the substitution reaction, an electrophile needs to be generated. So, what needs to be do first, what needs is generation of electrophile, that how we can generate any electrophile. Let us just first discuss, let me first discuss about the basic mechanism, how this substitution reaction will take place, and then we will go by the step by step. I think that will be more easy to understand. Okay. So, let us first discuss the mechanism, then we will discuss the details. Mechanism of electrophilic substitution reaction on benzene. This we have to discuss. Electrophilic substitution reaction, the mechanism of it. Okay. As I have already told, the first rule is, the first step is generation of electrophile. Okay. Generation of electrophile, it is not that I give the nitro group and a nitro group will be replaced, it is not like that. Electrophile has to be generated. Now, how this electrophile can be generated? There are different ways. Different electrophiles will be generated by different substituents and reagents. Okay. Different substituents, different reagents are needed for the generation of an electrophile. Let us discuss about the nitration. We were discussing about this nitration thing. So, how nitration can be, how a nitro group can be considered as the, or can be generated as an electrophile. So, let me discuss first. For nitration, we use concentrated HNO3 plus concentrated H2SO4. Okay. This concentrated nitric acid and concentrated H2SO4 will give us the electrophile NO2 plus. So, NO2 is not an electrophile, NO2 is a normal molecule, NO2 plus, it has a plus charge, that means electron deficient species, that is why it is considered as a nitro electrophile, it is an electrophile generated. So, this electrophile, nitration electrophile is been generated with the help of the concentrated nitric acid plus concentrated sulfuric acid. Okay. Now, for let us say alkylation, for alkylation what we do is we take some R, let us say RCH2Cl, and we react it with AlCl3. This AlCl3 is kind of a catalyst. This is Lewis acid. So, this alkylation and acylation, as I have discussed, it has a specific name, Friedel-Crafts alkylation or Friedel-Crafts acylation. So, what Friedel did is he has introduced a unique way to introduce the alkyl group or acyl group over the benzene ring, and he used the Lewis acid, one of the Lewis acid, that is aluminum trichloride AlCl3. What are the Lewis acid? Lewis acid again means electron deficient species. Electron deficient species, these electron deficient species are known as the Lewis acid. So, what happens is this Cl actually goes with the AlCl3, as Cl has lone pair of electrons, Cl has lone pair of electrons. So, it donates to the Lewis acid, that is AlCl3, and will form RCH2 cation and AlCl4 minus will be released. So, this is how the alkylated alkylated electrophile has been generated. This we have generated the electrophile. Okay. The third one is, let us say how the halogenation reaction occurs, how the halogen carbocation is created. Again using the AlCl3, it will donate its electrons to AlCl3, as it has 2 lone pair of electrons, actually 3 lone pair of electrons. So, it is an electron rich species, and AlCl3 Lewis acid is an electron deficient species, Lewis acid, and this is kind of Lewis base kind of thing. So, it reacts and it forms a Cl positive and AlCl4 minus will be formed. So, this is how a Cl positive, that is a chloride positive Cl positive electrophile can be generated. I also discussed about Friedel-Crafts acylation. Now, what acylation is? Acylation is nothing but RC double bond O group. This group is called as acyl group. Now, how its carbocation can be synthesized? That means, what I am saying, that replacing a H by this thing. So, this is known as the acyl group. Okay. Now, how this carbocation can be generated means how acylation will be done, which carbocation will be generated through the acylation reaction, that is, let us take similarly like alkylation, as they both were discovered by the Friedel-Crafts. So, they are named after him, Friedel-Crafts reaction, Friedel discovered it, and again this Cl goes over there and it forms RC double bond O positive plus AlCl4 minus. So, this is how an acyl carbocation can be generated. This is acyl carbocation, it is called acyl carbocation. Okay. So, this is how the generation of electrophile occurs. That was our first step towards the substitution reaction. Now, the second step was formation of formation of carbocation intermediate. That means, in all these reactions of all electrophilic substitution reaction of benzene, it processes via an intermediate formation, and that intermediate is a carbocation. Now, what carbocation is formed, that we will see. Okay. Now, what happens is, okay, electrophile is there. I am representing all the electrophiles with the help of a common variable E. So, now what happens is, this electron rich moiety gives its electrons to the electrophile, and what happens is let us say E is substituted on this carbon. It can also be substituted over this carbon, but both of the carbons have the same value. That is why any of one you can choose. There is one hydrogen here, and it will form a carbocation on this species. So, what actually is happening in this reaction is this double bond is breaking, and how this double bond is breaking? Let us say double bond is breaking like this, and it will give this minus and this plus here, and this now reacts with electrophile, and the electrophile will go on to that carbon which have the higher electron density, and negative, if there is a negative charge, that means that carbon has more electron density. So, the electrophile goes over to that carbon, and the other carbon gets the positive charge and forms a carbocation. Okay. Now, this reaction is the rate determining step. This step actually is a rate determining step, and it is also a slow process. Okay. Now, what why this is a rate determining step, why this is a slow process is actually what we actually having is, this is an aromatic compound. Okay. This is an aromatic compound, benzene is an aromatic compound. Let us see whether this compound is aromatic or not, whether this compound is aromatic or not. Okay. How we can say is this, do all the molecules have planarity, we have checked, that means sp2 hybridized. The carbon containing a carbocation is a sp2 hybridized. Okay. This carbocations are sp2 hybridized. Okay. So, it do have planar moiety. Conjugation, that means the ring entire conjugation, is it there, or the third one is the 4n plus 2 pi electron. Okay. This is an electrophile. Okay. This is an electrophile E. It do not contain any new electrons that it can donate towards the ring. Okay. So, if we see actually this whole moiety is not actually the planar molecule, as this carbon is not sp2 hybridized, this carbon is sp3 hybridized. So, first step only, that the molecule is planar or not. So, this molecule is not planar, and this is not an aromatic compound, that means not an aromatic compound. So, what we actually having is, we are going from aromatic compound to non aromatic compound, that means loss of aromaticity. One thing you must remember in chemistry, that wherever this word comes aromatic, the first thing that should strike into your mind is the stability. Aromatic compounds are very much stable. If something is going from aromatic to non aromatic, that means it is losing its stability, or losing its stability aromaticity, and any molecule in this world will not actually want to lose its stability. That means this molecule, we are forcing this molecule to lose its stability and be the non aromatic compound. So, this actually is a slow process, nobody wants to leave the stability it has. So, this is a slow process, and the slowest process in any chemical reaction is the rate determining step. Okay. The formation of this carbocation is the rate determining step. Now, one question that must strike into your mind, if loss of aromaticity is happening, then why does it react? Okay. if actually this aromatic compound is going towards a non aromatic compound, then it should not be reacting, it's why it's leaving its stability. So there should be something that's driving that benzene molecule to lose its stability, that means it is getting something else, that means there should be a driving force. Okay. Now, what driving force is this? Nobody, as I have told ki why benzene would like to lose its aromaticity, or we can say the stability, but what we are doing is if it is losing, we know it is losing, okay, these reactions are profine reactions, these reactions do happen. So, why is this happening is there is only one explanation to it, that the stability it is getting from somewhere else. So, where else it is getting the stability, the extra stability, that it's happening, that the case is happening that it is leaving its the aromaticity. Now, what is the driving force is? The driving force is the resonance. Okay. The resonance happens in this reaction. Now, what resonance actually do happen? What kind of resonance on reaction of electrophile this resonance provides to the benzene ring, that it can leave its aromaticity and be a non aromatic molecule. That we will discuss it, how that resonance and which resonance is stabilizing this aromatic ring, that we will discuss in the later classes. Thank you.